Hello everyone, and I welcome you to my video class on concrete technology. And today we are mainly discussing about high performance concrete, right? And its short form it is also called as HPC, right? So myself Vishwanath Auti, and we'll see that today's content we are mainly discussing about introduction part of HPC, high performance concrete, and different materials which are used for preparation of high performance concrete, then behavior of HPC in a fresh condition, next behavior of HPC in a hardened conditions, and in upcoming video, right, a video 2 of high performance concrete, we are discussing about advantages, limitations and applications of HPC. So now we'll go for, right, what do you mean by high performance concrete? So high performance concrete is a concrete mixture which possesses high durability, which possesses high durability and high strength. High strength comparatively with the conventional concrete. If you see the normal concrete, it has a high strength and high durability, and even it has a many features like high strength, smooth fracture surface, low permeability value, smooth fracture surface, low permeability value, and discontinuous pore with comparatively the normal concrete. This is due to low water to cementitious material, low water to cementitious material ratio, and presence of cementitious material and chemical admixtures. So actually we are like no, we studied low water cement ratio, right? So but in this we are using some of the cement replacement materials, and those cement replacement materials are called as cementitious materials. So that's what now we are using, water to cementitious material. So now in this concrete we have a low water to cementitious ratio, right? And why? Because of presence of cementitious material as well as like no chemical admixtures. Chemical admixtures means superplasticizers, right? We know what you mean by superplasticizers, which are reducing the requirement of the water. And then we have a retarders, right? So retarders help us to make the reduction of initial hydrations and even air entertaining agents. So due to this we are getting a low water to cementitious ratio and good workability. Next, high performance concrete works out economical. So works out economical means it requires the less to overall investment. So overall, why I use the overall investment? Why? Because investment is required for construction as well as investment is required for maintenance. So here investment for construction is little higher than the normal concrete, but it required less investment for the maintenance like a repair, right? Repair and some other works, right? It requires less maintenance cost. That's what it is called as works out economical, means good condition, right? And you can see this in the figure, like how complicated structures are there. To construct these kind of structures is required like no very workable concrete. So to make like this very complicated structure, we can make this kind of structure with the help of high performance concrete, because it can takes any shape we are required, and it gives the very good aesthetical conditions. So next will study what are the different materials used for to prepare the high performance concrete, right? So same as how we are preparing normal concrete or traditional concrete or conventional concrete, similarly we are using the same materials almost, but little changes about the some of the materials, right? So now we will see one by one, right? One is water, right? So water is an important ingredient of concrete as it actively participate in chemical reaction with the cement. So water we are using to mainly to mix the different ingredients which are using for concrete preparation, as well as it takes the main role in a chemical reactions or active chemical reaction in with the cement as well as in the paste. So that's what. So even water quality is very important. So even water standards are there to use for construction. We cannot use all type of water. It has some standards, and within standards only we have to use, and generally we have to use clean water, fresh water, and free from the contaminations. So next, cement, right? Cement is one of the binding material. We are not completely avoiding the cement, we are using the cement, but percentage is less, and this can be replaced with the cementitious materials, that is mineral admixtures, right? So here physical and chemical characteristics of cement play vital role in developing strength and rheology. So here chemical properties of the cement, physical property of the cement takes the main role in a development of the strength and durability of the concrete. So that's what we have to take care about it. And for high performance concrete, so here suggested is what low C3A concrete is best, right? So here it is preferable cement is what low C3A cement. It is good because it gives the good rheology. So next is fine aggregate. So we require aggregate. So in that aggregate, fine aggregate, right? So fine aggregate for high performance concrete, it is both are used, like no, even natural sand also used and artificially prepared sand also used. So natural sand means what? River sand, red sand or other river sand based on the geology, based on the topographic area. We are getting different colors of the river sand. Some places we are getting red sand, some places we are getting gray sand, right? So here for high performance concrete, it's not mandatory that we have to use the river sand only. Even we can use the M sand, which are prepared in a stone quarry or crushed stone fine aggregate. We can see here it is fine aggregate of natural river sand and M sand, right? So next we'll go for coarse aggregate. So coarse aggregate is also very important, and it takes the main, like no, actually if you see, the coarse aggregate is the strongest, it is the strongest and least porous material, least porous component of concrete, and selection of coarse aggregate is crucial. Crushed rock aggregate are preferable. So for high performance concrete, if you see, coarse aggregate takes the main role, and due to the main role we have to take care about it. It takes the main importance. Why? Because it is the strongest part, and even it is the least porous material, and it gives the main part, right? So here if you want to use preferable is suggested is crushed rock aggregate. Crushed rock aggregate are preferable. Next, we'll go for chemical admixtures. So, chemical admixtures are the essential ingredients in the concrete mix, right? Essential ingredient for high performance concrete. I'll tell you why it is very essential ingredient for the concrete mix, right? So they increase the efficiency of the cement paste. It increases the efficiency of the cement paste by improving the workability of the mix. Even it increases the efficiency as well as the workability of the mix, right? So then now what kind of different chemical admixtures we are using? We are using plasticizers, we are using super plasticizers, even we are using retarders and air entertaining agents, right? So plasticizers and super plasticizers mainly we are using to reduce the requirement of the water in the concrete, right? And to maintain the low water cement ratio or low water to cementitious ratio. And next we are using retarders. So retarders we are using to reduce the initial rate of hydration or initial setting time, right? So next we are using air entertaining agents. So air entertaining agents we are using to mainly to produce air bubbles, right? Air bubbles we have to produce, and why? Because it makes the some importance, and it gives the placing, and it gives the good workability. So that's what air entertaining agents you use to create the air bubbles. You can see here it is, these are the chemicals which are used, right here, chemical admixtures. Next, we are using mineral admixtures, even it is also called cementitious material or additive or replacement to the cement materials. So here, rapid catalyst used for rapid catalyst to gain the earliest strength. So mainly it is used as a catalyst, like no silica fume. So silica fume mainly used to make the rapid catalyst in the concrete or reactions, right, to get the early age strength. But even we are using fly ash, right? So if we see the some of the mineral admixtures, fly ash. So we studied what you mean by fly ash, right? It is what one of the byproduct of thermal power plant. So in thermal power plant they are using coal, right, to as a fuel to heat the water. After heating the water they will generate the steam, and from the steam they make rotation or turbine, right? So after burning huge coal we are getting, finally we are getting ash. So that kind of ash is called as a fly ash. So now here it has a disposal problem, right? It is one problem. If you see the problem of one fly ash is it is disposal problem, because it considered as one of the solid waste earlier. And even in a construction we required a cement. So cement has a, some of the, it cement is not economic eco-friendly. So it has the emission of carbon dioxide and as well as the heat of heat. So even we are reducing the content requirement of the cement, as well as even we are solving the problem of solid waste. So fly ash we are using. Next we are using GGBS granulated, right? GGBS ground granulated blast furnace slag. So in short it is called as a GGBS. So GGBS is one of the byproduct or waste which is generated from the steel manufacturing, all steel manufacturing, right? So even here same, it has a disposal problem, even reducing the disposal problem, and we are making economical as well as less cost of the concrete. And next we are using, as I told, silica fume. Silica fume is also one of the byproduct of silica metals and carbon block powder. So you can see in the images it is what GGBS and fly ash, right? Silica fume, correct. So next we will go for behavior of fresh high performance concrete. So what are the behavior of high performance concrete in a fresh condition, right? So one is workability. So we know workability is very important for the strength of the concrete, right? Initially in a fresh condition, workability of high performance concrete is good normally good. Even at a low slump, even at a low slump values, and high performance concrete typically pumps very well. So pumping capacity, and due to cementitious material, again mainly it is due to cementitious material and the presence of chemical admixtures. So due to the presence of chemical admixtures as well as the cementitious material, so due to this only it is as a different from the normal concrete, and it has a very good pumping capacity as well as it has a good workability. HPC has been successfully pumped up to 80-story building. So you can pump up to 80-story building, but we have to take care of in between the like no stable, like no some conditions, and even we can go for higher than that also, right? So ability to fill, it is mainly because of ability to fill the heavy reinforced sections. It is ability to fill heavy reinforced section without internal and or external vibrations. So it is like no self-compacting concrete, similar property of self-compacting concrete, and it has the ability to fill the heavy reinforced section without internal as well as external vibrations. Next, without segregation, it makes the without segregations, without developing large size of voids. So that's what it has a good workability. Next, setting time. Setting time can vary dramatically depending on applications and the presence of setting modifying admixtures and percentage of paste composed of Portland cement. So here setting time of the fresh concrete, it mainly depends on the use of chemical admixtures as well as the normal cement or Portland cement. So here the use of large quantity of water reducing admixtures like no retarders, right? Chemical admixtures, right? Chemical admixtures in that retarders can signify extend setting time. They can extend significantly setting time, and mainly here dosage dosage to be monitored closely with the mixture containing substantial quantity of mineral admixtures. So actually when you are adding retarders, we have to add with very carefully with comparative with some other additive materials. Additive materials are mineral admixtures, and even with other, because excess amount of chemical admixtures is also dangerous. So you have to take care about it, and mainly setting time is mainly depends on the use of chemical admixtures and even use of mineral admixtures, and mainly it is because of chemical admixtures of retarders. So next is behavior of hardened concrete of high performance concrete. So we'll study now what kind of behaviors are there of high performance concrete in a hardened state. So first one is strength of the concrete. The strength of the concrete depends on number of factors. So it is not only one factor, it depends on the many factors, including properties, proportions of the constituent materials, degree of hydrations, rate of loading, method of testing, and specimen geometry, right? So here strength of the concrete we are not testing on the site, right? Many time, many places we are testing in the form of cube, right? So here when we are testing the cube, even we have to take care about it. Why? Because specimen geometry and method of testing, it is very important, and even rate of loading, right? So that's what it depends on the many factors, and I'll repeat again, it mainly depends on the properties of the materials, proportion of the materials, degree of hydration, rate of loading, method of testing, and specimen geometry. So now we will see mainly about compressive strength. Why? Because concrete is good in a compressive strength, right? So maximum practical achievable compression strength have been increased steadily over a year. So now because of the innovations like different concrete, so now we are increasing the concrete strength, right? So here for 28 days strength we are getting up to 80 MPa for 20 days of days of curing, and we are getting in 80 MPa, and even we are getting higher compressive strength of 90 days. If you see the 90 days of testing, even we are getting up to, in some places they made test and they made research, even they are getting high performance concrete strength up to 130 MPa. 130 MPa, very huge, right? And even for the future they identified they may get up to 140 MPa, even they can get up to 140 MPa. Because of this only it is called as a high performance concrete, is good in strength as well as the performance future concrete. Next is tensile strength. As we know, tensile strength of the concrete is low, but if you take the total in a hardened condition means what? It has a reinforcement, right? So that's what we have to take with the reinforcement in hardened conditions. The tensile strength governs the cracking behaviors. See, the cracking behaviors of the concrete and affect other properties such as stiffness, damping actions, bond to embedded to steel, and durability of the concrete. So here tensile strength of the hardened concrete, it depends on the mainly about the dampness or dampness action, stiffness, bonding between the concrete and steel, durability of the concrete, right? So next we'll go for durability. So durability, the most important property of high performance concrete. So why? Because it is good in strength as well as durability. So it is one of the main behavior of hardened concrete of high performance concrete. Distinguishing, right? I'll repeat, the most important property of high performance concrete, distinguishing it from conventional concrete, it is far higher superior durability. It is far higher superior durability, and with very compacted material with a very low permeability. It has a low permeability as well as high durability, right? Right. So durability is very good, and it is one of the important property of high performance concrete in a hardened state. So these are the some references which I used to prepare my slides, right? One is MSAT book, then high performance concrete of some online websites, and these two websites I used to get some of the materials, and even some part to study about super plasticizers and all. We use the MSAT book, and even you can refer for more knowledge, right? So I think you understood. Thank you for watching my video.